Okay, students, in this video, we will derive Poiseuille's equation for streamline flow of the fluid. Okay, so in this, you can see in the diagram, there is a capillary tube. This is the capillary tube, and it has radius A and length small l. And suppose liquid is or any fluid is flowing through this capillary tube. Okay, so flowing liquid is flowing, so we have to derive an equation for that. Okay, so now, so theoretical part, consider a capillary tube of length l and radius a as shown in the figure. So consider a cylindrical layer of liquid coaxial with tube of inner radius x. So we will consider that small layer of liquid because we know that liquid don't have any definite shape from which type of the body or shape of the body it is flowing. It takes the same shape of the body through which it is flowing. So here capillary is cylindrical shape, so liquid will also uh, uh, you can say take the shape of cylindrical. So consider a small cylindrical part which is having a radius x. This is radius x, and just beyond x there is a one more radius x plus dx, or you can say this is the distance from the axis of the cylinder. Okay, so that is what our now we axis x and outer radius x plus dx. We are considering here x and dx because we will derive required equation for small part of the liquid, and then we will integrate it, and by putting proper limit of integration we will find the required equation for whole capillary tube. So therefore we are considering here a small part flow of the liquid through a capillary tube is steady. This is the assumption which we have to consider, that flow of the liquid is steady, and the velocity of the liquid at a distance x from axis of the tube is v, and at a distance x plus dx is v minus dv. Why v minus dv? Because in this case we already know that when liquid flow through any pipe or through any capillary, so at the center velocity of the liquid is maximum, and as we go up or we go down, velocity of the liquid decreases because of viscosity, and therefore this x have velocity v, and this radius x plus dx has velocity v minus dv. Obviously it is going to be less compared to velocity at x, therefore it is written here v minus dv. Now according to Newton's law of viscosity, viscous force or retarding force acting tangentially on a liquid layer is given by. So we this part we already derive in the equation, very small derivation. You can go for it, and if you have any doubt then you can ask me in the classroom. I'll explain you. So this is the concept. So this is Newton's law of viscosity, and that is given by F is equal to minus eta into area into dV by dx, where eta is the coefficient of viscosity, A is the area, and dV by dx is the velocity gradient. Students, gradient is a word which is used where any quantity changes with respect to a distance. So therefore dV by dx is the velocity gradient. Now A is the area, so we can easily write surface area of the cylinder or cylindrical shape of the liquid which we have considered here, cylindrical shape of the liquid, because liquid, when liquid will flow, this also follow the cylindrical shape. So is equal to 2 pi xl. We know that very famous formula for area of the surface area of the cylinder is 2 pi rl, where r is the radius, in this case x is the radius. So we can, by putting the value of area here, so we can write F is equal to minus eta 2 pi xl. uh, Please take care, this is x, not multiplication sign. So minus eta 2 pi xl into dv by dx. So this is the force, or you can say retarding force. Now since liquid is flowing, so therefore it must have some pressure, and because liquid always flow because of pressure, if there is no pressure or no any reference at from a reference level, there is no energy, then liquid will not flow. So let P be the pressure between two ends of the capillary tube. So I can write F is equal to P pi x square. How this equation came? P pi x square, because we know that pressure is equal to force upon area. Hence we can write force is equal to pressure into area, and area of the considered liquid layer is pi x square, that is pi r square, because it is cylindrical in shape. So area is pi x square, and x is the radius of liquid layer which we considered in this case. Okay, now since the motion is steady and streamlined, hence according to the condition we can write accelerating force must be equal to retarding force, because there is a pressure, so there must be a force, and there must be force, definitely there will be acceleration. So that accelerating force equal to retarding force. So then this is the concept, you don't have to forget this concept, because in streamlined flow this has happened. So from equation 1 and 2, we derived this equation, minus eta 2 pi xl dv by dx is equal to p pi x square. So by doing mathematical transfer, simple mathematical calculations, so dv is equal to minus px 2 eta l into dx. So this equation is very important to understand. So this is the small change in velocity dv at small distance dx. This equation gives this information. Here P is the pressure. So now for small distance, this is the velocity, change in velocity. So what is the total change of velocity? We can get this value by integrating this equation. So now integrate it. So integration of dv is equal to minus px 2 pi l into dx. Now student, we already know that we perform integration on variable quantity, not constant quantity. So here pressure is the constant, 2 is a number which is constant, x eta is the coefficient of viscosity which is also constant for given liquid, and so we will take out this term, because length L is the length, and length is also constant. Capillary is not going to change, length of the capillary is not going to change because of flow of the liquid. So this term will come out and we will integrate this x dx. So after integrating we will get v is equal to minus p 2 eta l, and integration of x is what, x square by 2 plus c. C is the constant of integration. Now we have to find the value of this c. We can find out by putting proper boundary condition. So what is the boundary condition here? At x is equal to a, means the liquid we consider small part of liquid. When we move to the upper part, that is when we complete a radius a, so velocity will be 0. Velocity of the flow of the liquid will be 0 at uppermost part. So by putting this value, so we will get required equation. So v is equal to 0 is equal to minus p a square 4 eta l plus c. Here a, because x is equal to a, we have to put. So c is equal to, we will get p a square 4 eta l. Now we have to substitute this value of c in equation 4. What is the equation 4? This is the equation 4. So in this equation we have to put the value of c. We already got here p a square 4 eta l. So we will get velocity is equal to minus p x square 4 eta l plus p a square upon 4 eta l. By doing simple mathematical calculation, we will get velocity is equal to p square 4 eta l and a square minus x square in bracket. Okay, so this gives the velocity of the flow at a distance x from the axis of the tube. So we can find out the velocity of flow of the liquid at any distance through the capillary. Okay, now we are interested to find the volume of the liquid flowing through cylindrical cell. How much liquid is flowing? So we will same manner we will consider small part and make an equation, and again we will integrate. So we will get volume of the liquid from whole capillary tube. So what will be the volume of the liquid? dq is equal to velocity of flow, means at what speed liquid is flowing, into area of cross section of cylindrical layer of radius x and thickness dx. Okay, so dq is equal to v into 2 pi x dx. Student, don't forget this equation, this term, because this is very important. So you will forget, then you cannot derive the equation. So dq is equal to dv into 2 pi x dx, where v is the velocity. We already got velocity, so put the value. So P upon 4 eta L a square minus x square into 2 pi x dx. So therefore dq is equal to pi p 2 eta L a square minus a square x minus x cube dx. So student, we got small volume of small area and thickness dx. Now we will integrate this quantity. So when we will integrate this quantity, we will, by putting proper boundary condition, we will get the amount of liquid for whole capillary tube. So hence the volume of liquid passing through whole tube is q is equal to integration of dq, and here limit of integration is 0 to a. So therefore pi p 2 eta L, because these terms are constant, will come out the integration of 0 to a square x minus x cube dx. So therefore we can solve it. So pi p into divided by 2 eta L a square minus x square divided by 2, because integration of x is x square by 2. Here a is the radius of capillary and which is fixed. This is not changing, therefore we will not integrate this a, and minus, and integration of x cube is equal to x square by 4, and limit 0 to a. So in this case, so q is equal to, here q is equal to pi p 2 eta L a square by 4. So we can write here eta is equal to, this equation eta is equal to pi p a raised to 4 8 L cube. So student, this is the equation, required equation we got here. And sometimes university also asks for assumption made to derive a Poiseuille's equation for a streamlined flow. So these are the assumptions. Assumption number 1, flow is steady and streamlined. Let me clear all the marks. So number 1, flow is steady and streamlined. Number 2, liquid in contact with sides of the tube is at rest. Number 3, pressure is constant throughout the tube, because if pressure will change, so we will, this equation will not be valid, because here we consider pressure is constant, hence we have not integrated this pressure. So hence pressure is pressure is constant throughout the tube, and tube is horizontal, because if tube will not be horizontal, then there will be the pressure difference between two end of the tube. So these are the 4 assumptions we made to derive Poiseuille's equation. Hope I clear each and every doubts and queries, whatever you have. And still, if you have, then you can ask me in classroom, and I'll clear remaining doubts and queries. Thank you so much for watching this video.